In this video, we're continuing section 1.1 on numbers and sets, and we are going to focus on some common exponent errors that involve order of operations. So I want to do an example that is a true-false question, and for each part, we have to explain our reasoning. So part A says negative 3 squared. This symbol means is an element of. So this is saying negative 3 squared is an element of. Remember, this capital N like this is the symbol for natural numbers. So is negative 3 squared written like that a natural number? Okay, so there's a difference between when I write negative 3 in parentheses squared versus when there's no parentheses and then I square it. And the difference is that when you have a parentheses, you deal with the stuff inside the parentheses first, according to order of operations, and then I square that quantity. So that is negative 3 times negative 3. So negative times a negative is a positive. So this is positive 9. If there's no parentheses, well then order of operations says deal with the exponent first. I got to square the 3 first and then deal with that negative in front. So squaring the 3 means do 3 times 3 and then deal with the negative after that. So 3 times 3 is 9. Then the negative gets stuck in front of it. So that's negative 9. But a negative number, and that's what this one is, there's no parentheses, so it's a negative 9. A negative number is not, so I'll put a slash through the symbol, is not an element of the naturals. So for that reason, part A is false. Is it a natural? No, it's not a natural. Okay, what about B? In B, it's the same quantity, but now it's saying is it an element of Q? And that's the symbol for rationals. Well, we just saw that negative 3 squared like this is negative 9. So can I write that as a fraction of integers? And yeah, I can do it in many ways. Like I can do negative 9 over 1. I could also do like negative 18 over 2. There's many ways I could write it as a fraction of integers. So it is a fraction of integers like I need. So as a result, well, this whole number is an element of Q. It is rational. So as a result, well, part B is true. It is rational. Okay, let's move on to part C. So in C, I have square root of 2 minus square root of 3 in a parentheses, and then that whole thing is being squared. And it's asking, is that an element of Z? Remember, Z is the symbol for integers. So I'm going to first do this. I'm going to first simplify it incorrectly because I'm going to make a very common but important mistake, something that I very frequently see people in our class make. So I want to point it out and be very explicit about it. So the mistake is when we see something like this, to see that exponent and kind of be like, wee, and bring it to the first term, and wee, and bring it to the second term. Because if I did that, we would get square root of 2 squared, and then minus square root of 3 getting squared. Okay, and if I square that square root, well, they cancel, and I'll get 2. And if I do the same thing for the other square root, if I cancel it with the squared, I'll get minus and then 3. Well, that's negative 1. But that's not right. It turns out, actually, that wouldn't make sense based on what I had originally, because if I'm starting with something being squared, there's no way that that should end up being a negative number at the end. So something clearly must have gone wrong. Okay, so I want to talk about this major rule break. So the rule break is, if I'm either adding 2 terms or subtracting 2 terms, and I raise the whole thing to a power, which I'm calling P, I cannot distribute the power like I just did. So this first one is not just a to the P plus b to the p. And similarly, if I'm subtracting, it's not just going to be a to the p minus b to the p. That's a major rule break. It turns out I can't distribute a power when I am adding or subtracting the terms. However, I am allowed to distribute the power. I can distribute the power when I'm either multiplying or dividing the terms. So if I have a times b inside of the parentheses, the whole thing to the p power, well, that is a to the p times b to the p. That one works. So I'm actually going to highlight that one. That one is the one that works. The other two are rule breaks. They do not work. Okay. Well then, how do I actually simplify something like this? Like, what's the correct way to do it? So I want to have you give the video a quick pause for about 1 minute and see if you can try to work it out in the correct way. Pause it in 4, 3, 2, 1. Pause the video and see if you can work this out the correct way. All right, so hopefully you did that. Hopefully you paused it. If not, go ahead and give it a quick pause and try it. All right, so let's talk about it. Okay, so what's the correct way to square this thing? Well, squaring something means I multiply it by itself. So let's write this thing multiplied by itself. So to multiply this thing by itself, I have to FOIL it out. So when I FOIL it out, I'm going to first multiply these first two terms together. So that's going to give me square root of 2 times itself. So that's square root of 2 squared. And then I'll get the first term times the last term. So that's the outer terms. That's going to be minus root 2 times root 3. And then I multiply the inner terms. So that's going to be minus root 3 times root 2. And then finally I multiply the last terms together. So that's going to be 2 negatives multiplied makes a positive, plus root 3 squared. Okay, well, I know this first root 2 squared will cancel the root, and I'll get a 2. I know this last term will cancel that root, and I'll get a plus 3. And then, well, if I have a square root of 2 times square root of 3, well, the square root stays, and then I multiply the things inside of the roots together. So 2 times 3 is 6. Same thing with this one. You know, I'll have the root stay, multiply the insides together to get that 6. Okay, so this one, of course, had a negative in front. This one had a negative in front. So if I have negative root 6 minus root 6, I have minus 2 root 6. That's kind of like if I had negative x minus x, I have negative 2x. Same reasoning for why this is minus 2 root 6. Okay, so the 2 and the 3 add to give me 5, and I get 5 minus 2 root 6. So the original question was, well, is this an integer? Well, 5 is an integer, but 5 is being subtracted by this root term, which doesn't simplify nicely. So that square root of 6, well, that's not an integer. When you multiply by 2, it's still not going to be an integer. It's going to be some irrational thing. So overall, this whole thing is not an integer. So as a result, well, it's false. The problem was claiming it is an integer, but it's not.